Okay, Unit 6.1. In this unit, we're going to learn about polygons. First, we have to understand what is a polygon and what do these terms mean, side and vertex. Or sometimes when we use plural, we say vertices. That's V-E-R-T-I-C-E-S. That's the plural form for vertex. So a polygon is a plane figure that's formed by three or more segments called sides. So in other words, for this triangle, for example, if we call this triangle ABC, it's formed by three sides, and each side is a segment, right? A, B, B, C, and AC. And it also has three vertices, which is A, B, and C. And that we just write A, B, C like that. So by the same definition, if we look at this rectangle, A, B, C, D, we have four sides and then four vertices, right? And this is a pretend square. We can call this X, Y, Z, U maybe. And it's also four sides and four vertices. And here's a parallelogram, and here is just another one that's not a parallelogram, but it has four sides. It's a quadrilateral. And this is a hexagon, and this is a pentagon. So this one has five sides. If we want to label this one A, B, C, D, E, and so there are five C, D, E, five vertices, and there should be five sides, and each side is a segment. C, D, D, E, and then finally EA. Okay, so that's the definition of polygon side and vertices. Now let's look at the what's a diagonal of a polygon. A diagonal is also a segment, but that segment joins two non-consecutive, meaning consecutive meaning connected, non-consecutive meaning not connected, not connected. Not connected vertices. So in other words, you find two vertices that's not connected. So A and B would be connected, right? So rather than A and B, I do A and C. Maybe if I change the color. So I can also do A and D. Those are two vertices that are not consecutive. That's not connected. E and B is another one. B and D is another one, and E and C is another one. Maybe I'll do this one red as well. See the star, the red star inside in the pentagon? Those lines, those red lines, are called diagonals of the pentagon. Now, if I have to do this big rectangle, I have two of them. I have BD, and I can connect AC. Anything else, if I want to connect AB, notice that I have a side. I connect AD because these two are connected. These two vertices are right next to each other. It's not a diagonal, rather it's a side. Okay? So finish the follow-up on your own, and let's look at the examples. In the first one, is this figure a polygon? And our answer is yes. And it's a polygon formed by four straight sides, right? Notice for the second one, the answer is no, and the reason for that is that it has a side that's not a segment. In other words, this side, this curved line, is not a segment, it's a curved line. So the answer is it has a side that is not a segment. Okay, and then the third one, obviously, it's not a polygon as well because two of the sides intersect only one other side. So because two of the sides, 2 out of 4 sides, meaning this one and this one, 2 of the sides intersect only one other side. You really need to intersect, look at this one, this line needs to intersect on both sides. Okay, so that's the first example. Excuse me. And finish with this follow-up, and then let's look at example 2. Let me move it up a little. So we have to decide whether the figure is a polygon and then explain the reasons. Excuse me. The first two, A and B, obviously they are polygons. The first one has 4 sides. So, oops, let me change it back to blue color. The first one has 4 sides. So for 4 sides, we call it quad means 4, right? Quadrilateral. Okay? Then the second one, we have 1, 2, 3, 4, 5 sides. And for 5 sides, we have a pentagon. Oops, I misspelled it. Pentagon. And of course, what we're most familiar with when we write pentagon with a big P, we all know where that's located. That's in DC, right? And pentagon, it literally is, it's because the building is built as a pentagon with 5 sides. And the third one, this is a tricky one. Is this a polygon? If you verify it with the definition, the definition said that each side has to connect with 2 ends. But look at this. I've got it intersect other sides 3 times. So therefore this is not a polygon because some sides intersect more than 2 other sides, right? So we said some sides or 2 sides, this side and this side, intersect more than 2 other sides. Okay, so it's pretty straightforward. You just count the number of sides. If we have 3 sides, we have a triangle. We have 4 sides, we have quadrilateral. We have 5 sides, we have pentagon, so on and so forth. And also make sure that each side, like this pentagon here, each side has to intersect with another side, other sides on both ends once. This one is intersecting with too many sides. Okay? Make sure you complete the checkpoint. And let's look at some theorems here. Here we have a theorem that says the sum of the measures of the angle of a quadrilateral is 360 degrees, meaning if I have a quadrilateral, 4 sides, and if I add all the interior angles together, I would have 360 degrees. Angle measure of angle 1, angle 2, angle 3, angle 4, added together is 360. The easiest thing to think about this is probably to think about a rectangle or a square. And that's a special case, obviously. But in this case, I have 4 right angles. I have a quadrilateral, right, a special quadrilateral, and each angle is 90 degrees, and I have 4 of them. 4 times 90, I have 360. Okay, so just because this is an irregular shaped quadrilateral, is still the interior angles adds up to 360. Remember, when we have triangles, we add up if we have a triangle, right, the interior angles would add up to 180. And in quadrilateral, we have 360. Okay? So this is really interesting. This follow-up asks you to draw quadrilateral ABCD. So I'm going to just be lazy. I'm just going to use this quadrilateral, any random quadrilateral. And then it's asking me to divide it into two triangles by drawing diagonal AC. So if I just connect this point A with point C, oops, sorry. Why is that a triangle? I was trying to get to a line. If I do this, okay, this is really good. Now you can see by connecting the two vertices, I created a diagonal, right? Also notice that I have two triangles. So we know the sum of the angle measures of ABC, the top triangle, is 180. And the sum of the angle measures of ACD is also 180. That we learned a while ago. So therefore, if we add all the interior angles together of both triangles, I also get 360, which just proved my theorem right here on top. Okay, so let's see how do we use this in this example. If I have a quadrilateral on the right here, PQRS, and I need to find what is S here. Now, I just know, I don't know what S is, but I know if I add everything together, I should have 360 as the sum of the interior angles. And that's by the quadrilateral interior angles theorem. Now, if I just gradually replace one by one, angle measure for P is 70, for Q is 80, for R is 70, and I don't know S, and the total I know is 360. Now if I add all three together, I should have 220 degrees, and that's still 360. And if I subtract 220 on both sides, I end up having 140 degrees. Okay, so by using the quadrilateral interior theorems that we just learned, I found out what the last interior angle that was unknown to me. So pretty much use the same method. See if you can solve for these three problems. And that's the end of today's lesson. Make sure you complete your homework. Thank you, guys.
Come here.
This is Sparta!